All right, guys, the fourth and final part of section 1.12 on transformations. So what we're going to do in this lesson is we are going to simplify functions algebraically. So even though, if you look at this example up here, there's a transformation of times 2 with the y values and then down 3, we're actually going to not think of this as transformations at all, but just use algebra to simplify. Here's what I mean by that. We've got a function f of x, and then g of x is a series of transformations on f, okay? But to simplify this algebraically, because there's an f of x right here, and this is what f of x is equal to, we're just going to use substitution. We're going to replace f of x with x squared plus 2x plus 1. So if we do that, g of x becomes this. It becomes 2 times where there was an f of x. Now we're going to get x squared plus 2x plus 1. And then we're going to bring down that minus 3. All right, so g of x is still the same as it was right here. The 2 is still there. The minus 3 is still here. We're just replacing f of x with what f of x is equal to. All right, that was our first step. The second step to simplify this, well, we could distribute this 2 now. So we could distribute the 2 to all 3 terms. So that gives us 2x squared plus 4x plus 2. And then we still have that minus 3. And then we have 2 like terms that we can subtract. So if we just do 2 minus 3, that subtracts out to give us negative 1. All right, so that would be the answer to this one. This is just the way we simplify this expression algebraically. All right, same directions on our next one, but a different, two different transformations here. Now, normally when that b value is out front of the parentheses, that's how we want it written. But for what we're doing today with simplifying algebraically, we actually want to start off by distributing this 2. And so we're going to rewrite g of x, but we have to distribute that 2 first. And again, for all the other types of questions that we've done, you would not do this step. It's only when we're simplifying algebraically here. Now, this question is pretty different from the last one. So the last one had an f of x, right? So I could just take this and plug it in for f of x. But this one is not f of x, it's f of 2x minus 2. So what we have to do first, before we do anything else here, is we're going to take this inside, and we're actually going to plug it in to f of x. So let me just rewrite f of x real quick. And this can be a little bit tricky, a little bit difficult to see for a lot of people. So we're starting with f of x, but what we want to find is f of 2x minus 2. So function notation, whatever's on the inside always replaces what x is. So if I told you to find, for example, f of 1, well, you would just replace all the x's with the 1, and then you would simplify. So same idea here, there's just 2 parts to the inside. So we're going to take that 2x minus 2, and because it's in the place of x, we're going to plug it in right there, and we're going to plug it in over here as well for both x's. And so now it says this, where there was an x squared, now it's a 2x minus 2 squared. And where it was a 2x, now it's a 2 times 2x minus 2, and then we have that minus 3 at the end. So this is f of 2x minus 2. Now what we can do, all right, is go back over here. Right, f of 2x minus 2 is what we're looking for. So we're going to take this and just bring it back over here. So g of x, and I guess I could have copied and pasted to save some time, but I'll do it this way. And minus 3. Okay, so this is g of x, and this is correct. That might be how the answer is written. But if it's not, we got to talk through how to simplify this. So squaring something, you cannot distribute an exponent whenever there's addition or subtraction. So you're going to have to multiply 2x minus 2 by itself. Now, this 2 can get distributed. So that's a plus 4x minus 4. And then we have that minus 3. All right, move that up a little bit. So again, to keep simplifying, we have to FOIL or distribute both the 2x and the negative 2 to both terms here. So 2x times 2x is 4x squared. 2x times negative 2 is negative 4x. That also gives us negative 4x, and that gives us plus 4. All right, then we still have that plus 4x, and I'm going to combine those two to get negative 7 or minus 7. All right, last step is just combining like terms. And let's see, the negative 4x is going to cancel out with the positive 4x. So we're just left with that negative 4x. And then 4 minus 7 gives us minus 3. All right, so those are a little bit tricky, but that's how we do that one. And then the last one, if we get one like this, it'll be extra credit because these are pretty tough for people. So we've got stuff on the outside, and it's not just x on the inside, it's f of x plus 1. All right, so to figure out what g of x is in terms of f of x, off to the side, let me just copy this function real quick. All right, so off to the side, I'm first going to start off by figuring out what f of x plus 1 is. F of x plus 1. Well, again, that x plus 1 just gets plugged in for the x's, so it's instead of being 2 times x, now it's 2 times x plus 1, and we still have that plus 5. Now, this is f of x plus 1. I could just go ahead and take this and plug it in over here, but it might make it easier if we actually go ahead and distribute here. Doesn't matter if we do it now or later, but it might make it a little easier just to do it now. So 2x plus 2 plus the 5 right there, and so that's 2x plus 7. Okay, so that's what f of x plus 1 simplifies into. So now we can replace f of x plus 1 with what f of x plus 1 is equal to. So I'm going to come back over here, and we still have a negative 3. Where there was this, we're going to plug in that 2x plus 7, and then we still have the minus 2. And so now we're going to distribute that negative 3 again. And then there's two like terms to combine to just a negative 23 at the end. Now, this one wasn't horrible because I made the f of x function kind of easy. But if it was an x squared function, and I had something like this, again, it'll be more like the last question, but with even more once we end up with that right there. All right, so that's why these can get a little bit tricky. Some students are going to be able to master all three. Some are probably, we're going to be able to master the first one and at least part of the second one, and that's okay if that's all we get to. All right, I don't want us to get too discouraged with this because I know a lot of people have a hard time kind of figuring out what they're plugging into what. But that's the idea. Again, we'll practice in class. And again, don't stress too much if it's not clicking. All right, guys, stay flawless.